Okay, so our next speaker is Paul Calleja, who's Director of Research Computing at the University of Cambridge. He's going to talk to us about some of the work on AIRRFED. So, Paul, over to you.
Super. Well, it's nice to see a lot of old familiar faces. Maybe not so old. Where's the new young blood? It's just not happening, is it? Anyway, it is what it is. We'll all be dead soon. Then what happens? I don't know. With that joyful start. So today I'm going to talk about the AIRRFED project, which has been a upliftingly successful and fast-paced project. I think largely because of my new colleague Sadaf's input, which is like a breath of fresh air and a force of nature. So this is really a demonstrator project that was really born out of discussions with myself, Sadaf, and Jeremy Yates kind of over a year ago. We needed to kind of put a pane of glass across air resources and thought, how can we just do something quick to join up, create a joined up air service, and at the same time expose to UKRI the art of the possible as they sit down and reimagine what a DRI might look like if we ever get some funding. So, this will be kind of interesting of reimagining how a DRI could be based on the software tools and changes of technology that we have now. And so, but you don't know what you don't know. So this project was really meant to demonstrate what could be done alongside building an actual product for the air service. So I'm going to do the normal kind of background and context of what we do in Cambridge because it is relevant, and a little bit of a focus on an industry-funded innovation lab, which is again relevant. I'll quickly gloss over the air slides because it's been talked about already. I'll leave them in the deck for reference mainly, and a quick introduction to Dawn. I won't talk much about Isambard AI because you've talked about it a lot. I won't really talk too much about Dawn either. It's just an exemplar. And then we'll really focus on the meat of the talk, which is AIRRFED. So, talking about old, I joined Cambridge 19 years ago, which if you look at my LinkedIn picture, you'll see what I looked like then. It's not quite the same as I look now. And back, he's doing it, isn't he? He's looking at my LinkedIn picture. And really, 19 years ago, our focus was the use of kind of large-scale commodity compute clusters instead of traditional proprietary systems. And that was quite an interesting time. That was when Intel came out with their Core Duo processor, for anyone who can remember. And we managed to get number 20 in the top 500 for £2 million. It cost a lot more than £2 million now to get anywhere near that. Yeah, don't look the same, do I? So, people use that picture at conferences and walk straight past me. Yeah, you would. You roll forward to today, 19 years later, Cambridge is a significant member of the UKRI DSIT kind of national compute space. We collect quite a lot of projects. I guess I'm a magpie with projects and multiple kind of national and international HPC and AI activities. Obviously, we're a founding partner in AIR, we're EPSRC Tier 2, we're a Dirac site, we're an Iris site. We provide a lot of compute for UKAA colleagues who are here. We're also part of the SKASRC and the Excalibur HNS program and a climate RSE centre funded by Schmidt. And this gives us quite a large critical mass of projects and engineering resource. And there is a kind of a thread that runs through them. So we get economies of scale and we can be reasonably agile because we've already employed people. Because these one-year startup projects are really annoying because by the time the project's finished, you've got your staff and you're always having to borrow staff from other projects. And if you have a lot of projects, you can do that kind of agile reuse of staff. Apart from timesheets get tricky. But apart from timesheet kind of stuff, it's all good. And I guess today we serve a large kind of pan-UKRI community of around 4,000 users. And if you look at top 500 performance counters in the UK over the last 7 years, I think we provided around 48% of the UK's top 500 performance over the last 7 years, which is an interesting stat because I don't think I've had 48% of the funding. And we have quite a well-developed TRE focus, really driving a lot of our work in clinical medicine. We have a large push in clinical medicine at CUH in Cambridge. And we have quite a strong industrial partnership model. We've actually received over £80 million in industrial investment over the last 4 years. That's real cash and/or equipment, which is an interesting line item. And all this supports quite a strong in-house technology team for system design, system implementation and support. So we design and implement all our HPC systems. And of course, we operate them for our stakeholders. We also have a long-standing technology partnership that crosses quite a few countries in Africa. Partnership myself put a lot of effort into that activity, and it's really quite an interesting thing I can talk to you about over lunch. So if you look at the infrastructure and the people, we have around £100 million worth of equipment in operation in our data center. And none of that is over 4 years old. We get rid of equipment at the 4-year mark because I need the space and I need the power. So once things cross that 4-year line, they're marked to be weed. Actually, all our Cascade Lake clusters, which you've all funded over the years, are just about to be repurposed and shipped to Africa. So we're going to build out 10 Cascade Lake clusters and the support infrastructure to seed 10 universities across Southern Africa in the SADC development region, which is useful. So these machines have a second life. When you look at the data center, it's probably one of UKRI's leading water-cooled kind of AI-ready data centers in the UK. It's 1.8 megawatts of power and cooling. We have 100 racks. Represents around £30 million of investment from the university, 20 million to build it, and we're just going through a £10 million refresh now as some of the cooling infrastructure is aging out and needs to be replaced. And we have around 30 petaflops of double precision floating point performance across a very heterogeneous system, around 3,000 Dell servers, around 45 petabytes of storage, disk, NVMe, and tape. Obviously, we're a large luster house by background. We run an ISO 27001 compliance service for our medical data. And we run this all as a private cloud. This all sits inside one OpenStack tenancy. We've been doing this for a long time. This is supported heavily by Stack HPC, which it's good to have the SKA project here because Stack HPC were formed 8 years ago to help me with the SKA kind of SDP work run by Paul Alexander back then. And this is the Stack HPC, our prime example of the SKA, an academic project, creating a need, a company stepping in to solve that need, and then bootstrapping that out to a wider kind of, economic gain. So that's a really good example of our communities seeding a UK leading SME in this space. And many of you here, I know, work with them now. And that wouldn't have happened if the SKA project did not require that kind of functionality. But that's something we should know. We need to do more of that as a community. So I'll just leave this in for reference, really. All our infrastructure sits within this kind of OpenStack environment where you have kind of bare metal networking, OpenStack APIs, that can create kind of software-defined research platforms on top of an infrastructure. We have a separation of concerns between infrastructure management and science platform. This is key. It supports DevOps ways of working and really makes our DRI more like a commercial cloud with APIs, DevOps tool chains, and this separation of control. And I think, again, as we step forward and look at how a DRI could be reimagined, this separates that tyranny between location, infrastructure, science platforms, and support teams. And this is quite revolutionary in how we might provision community-based science platforms on top of shared infrastructures that are held at a number of centres of excellence across the UK. right? This is kind of key. And again, Irish, John, your project again was a very early demonstrator of how we do that. We run infrastructure for that group up in Scotland. I can never remember the name of that project, that astronomy project. Euclid. So Euclid is a prime example of we provide them the infrastructure. They run their platform. They support their platform. My support desk never deals with those scientists. Yeah, so you can have devolved support teams that don't have to be anything to do with the platform. And when we think about that, it makes us really flexible in how we can imagine a DRI. And I think that Euclid one was the first example of this that I came across, and it works really well. Okay, at the beginning, there's a little bit of roles and responsibilities, but once you get used to that way of working, it's really powerful. So just quickly to talk about the Z-Scale Lab. This is an industry-funded activity sponsored by Dell and Intel. It closely involves DIRAC, UKRI, UKAA. It was $10 million of real cash from Dell and Intel over a 6-year program. We just signed up the next 2 years of funding. This should give us around 15 to 20 FTE to work on a range of projects. This is relevant to this discussion. I'll come on at the end. And really the kind of the principle of the Z-Scale Lab is you have this kind of co-design virtuous circle where you have HPC users that give you the scientific need. You have HPC supply chain that provide the technology, and HPC providers like ourselves that provide the know-how. And you kind of mix that all together. You have a critical mass of requirements, a critical mass of experience and skills and infrastructure. And you can have kind of science-led proof of concepts. Yeah. The science-led is really important. Otherwise, you end up doing things that interest me and my engineers, but they might not make a penny's worth of difference to your users. Yeah. So it's always good to have that kind of science need pool to make sure what we're doing is actually valuable to the communities that we support. This has been a really successful activity. Dawn came out of this collaboration. The servers were designed out of this collaboration, and the machine was funded. The capital was funded through the lab with a very large donation from Intel. And they wouldn't have made that donation unless they'd felt comfortable that we were actually going to do what they thought they wanted. I'm not going to talk about this. There's a whole load of themes that the lab works on. Activity kind of waxes and wanes with these depending on circumstances, but there are a whole load of themes that the lab is working on. I think we all know about AIR and the concept. I'll flick over this slide. Dawn is the Cambridge element of AIR. It's got that consortium of companies. Cambridge, Stack HPC are heavily involved in the software environment. Intel, obviously, because it's using Intel GPUs, which are now a rare thing. UKAA obviously have involved in that design. DSIT and UKRI. It's still currently the fastest AI system in the UK, has been since November 23. So there's a lot of the server design and requirements came from us that they wouldn't have made that server unless we asked them to. It is run as a private cloud infrastructure. And we have a good collaboration just starting up now with Argonne National Labs, because of course they've got a lot of software and capabilities working on Aurora and are keen to help us exploit our system and collaborate with them, especially in some of the AI areas. It's a 2U server, GPUs underneath, x86 on top. One of the design features of this server was I wanted it to be 2U so that I could get 4 discrete network cards in there for message rate. So there's 4, each GPU has its own InfiniBand connection, which is crazy when you realize there are 1,000 GPUs. I'll just skip ahead. And that's the core switch to support those 1,000 GPUs. It's crazy. Obviously, I could not get NDR out of NVIDIA. So we had to build it with HDR. And that's what an HDR switch looks like if you want to support 1,000 links at full bandwidth. That's probably one of the fastest InfiniBand core switches in the UK at the moment. It's 34 kilometers of fiber cables, which is crazy. That's also quite crazy. That's the water system that's needed to cool Dawn. That was retrofitted into our data center because we have water at the back of the racks, but not water in the racks. So we had to deploy a direct liquid cooling system for Dawn because Dawn sucks a megawatt of power. So we had to deploy quite a large amount of water cooling infrastructure to cool that system. Okay, so from a software stack perspective, obviously it's an open stack controlled infrastructure, enables us to support true multi-tenancy, on top of which there'll be kind of two forks of access. So it's kind of traditional bare metal Slurm access, and then a more modern Kubernetes environment, allowing kind of things like Jupyter Hub, Kubeflow, and custom research platforms that we configure with a Stack HPC tool called Azimuth. And then there'll be a whole load of kind of software interfaces on top of that with various LLMs and AI tools that we're putting on from Intel. So Dawn has been in early science mode since for the last year. And we had an internal call across Cambridge with 140 users across 65 different projects. And it was surprising to me how easy it is with AI to get AI workflows running if PyTorch works. It's not like a simulation code, which is a difficult process to move from NVIDIA to something else because everyone's so embedded into CUDA. And porting large simulation codes for one API takes time. But with AI, it's very different. And if things work with PyTorch, it kind of just works. Okay, there are some performance tweaks, but functionality ports are almost instant. And performance is reasonable out of the box. And the air call is now out. Sophie talked about that, which is good. So please do apply. The EOI is now up and running. And people can get time on the system. There's quite a lot of allocation space at the moment. But interestingly, when we looked at our pioneer projects, it's not all LLMs by a long way, not in science. And this is something that I think DSIT, should be interested in. LLMs are a relatively small component of the AI algorithms that are running on Dawn. It's certainly in scientific computing, it's not all about ChatGPT. And this domain breakdown is really more of a reflection of Cambridge, I think, than the wider community, and more of a reflection of who our users are by legacy. A lot of the time you're fishing in the same pond, right? So it's your AI community. If you're an HPC person, are going to be AI people. I think the discussion earlier is really pertinent. We don't reach out to the humanities and social sciences because that's not where we live. And so bringing those communities on proactively, I think, is necessary. Otherwise, you get this kind of skew in your users. And there happen to be people that know how to use Slurm. And when you ask them, how do you want to use the cluster, they say Slurm. Because, of course, that's where they come from. Yeah, so we're wedded by our legacy. And our users in particular are wedded by their legacy. I'll skip through these. There's a whole load of AI projects. Let's skip to the meat of this. So AIRRFED was funded by the Excalibur HENS program. From discussions we had with Jeremy a year ago. It's Bristol, mainly it's Bristol and Cambridge. I forgot to put Durham on there. Durham been helping us with the data transfer work. So there's Bristol, Cambridge, Durham, and then two companies, Stack HPC, that I've mentioned before, and an Estonian company, Sadaf. Open that, Estonian, right? Yeah. So then Estonian company that have a web kind of portal that's heavily used across Europe on Lumi and other EuroHPC systems. And Sadaf brings experience there. So there are a few principles in AIRRFED that I think it's good to get out at the start of the talk. So it started last year. It was only a one-year project. So we had to do things fast. And so therefore, because we're going to do things fast, we wanted to be not afraid of just picking a solution and then it failing and changing it out later. And we had a small group, more of a coalition of the willing, to use the current phrase, and with strong agreement on core principles, especially on the design. And Sadaf, are you like my Trump? You had strong views, right? So Sadaf has strong views. It's strong views, strong technical views, and no messing with Sadaf on her technical views, which I find really enjoyable. And really, we had a firm kind of idea to spend maximum time doing and less time talking. So we really could have a product at the end of the period, not a research activity. And I come across this again and again with the SKA, especially in the early years, when academics have a tendency to pull in research kind of interests into a project which is producing a product. And there is a dilemma here in that we get funded by research councils, and I think that it's in the R, but this is not research, this is a product. And our communities fall down on this again and again, which is why almost every software product activity that I can think of in my long and grey-haired history fails completely. We talk about that at the end. I know none that work. But we can talk about that philosophically later. We want to learn by doing, demonstrate what could be done with a kind of a modern API-driven kind of software infrastructure within a DevOps development and deployment environment. I think that's kind of key. And the API-driven software infrastructure is key with a separation of concerns across that stack. We wanted to use existing portal technology from Europe. This was OpenNode and their product Bulldor, yielding this cloud-native user environment. We want to reuse products that exist already and contribute back, not reinvent the wheel and spend a year talking about what that wheel might look like. The other facet of this project is a very strong industrial partnership model to drive fast development, because I couldn't hire staff in that year. So we gave money to Stack HPC and used their staff. So we want to have open source, commercially supported software components. I think that's really key, because again, if we're successful and we show this product working, I don't want to die under the weight of having to support that product for the rest of the time. Because this is what happens, isn't it? You develop a product and then to operationalize it, that's a dog you can't give back. You've got to look after that bloody product forever. Academics we shouldn't do that. We should pass it over and let industry do that. So having industrial involvement from the beginning with a supported software environment frees us from that tyranny of dying under the weight of supporting the things we create. Otherwise, the more successful we are, the faster we're going to fail, because we can't support them and operationalize them. And I don't think we should. So with that said, what is AIRRFED? I had fun with my red ink this morning. AIRRFED provides a single pane of glass, a kind of graphical interface. I know I can't spell. You'll also know, apart from being grey-haired, I'm very bad at spelling. So just enjoy my spelling mistakes. It has been quite a pain as well. Anyway, there you go. A single pane of glass with a graphical interface for secured federated discovery, allocation, access, and usage. I think you have all those things. You've got to discover the resource, you want to allocate it, to access it, and you need to use it. Right, so it provides that kind of federated functions to national AI and HPC resources for both allocators, people in funding councils, and users. And those users should come from UKRI, they should come from government, and they should come from industry. So there are two halves of this. There's the allocator view and the user view. So firstly, obviously, it's designed to lower the barrier of access to national resources by creating a single, I've fallen into your trap, top level, holistic national gateway, right? For running calls, for responding to calls, allocating projects, awarding credits, redirecting requests, viewing what's going on. So this helps us with the administration of a national DRI? How do people know that calls are out there? How do they respond to calls? How do you, judge the calls? That whole kind of business logic of running a service. And then the other side of this, each HPC site then has its own specific customizable AIRRFED instance. So this is where you have the variation, okay? Each site does not have to implement that AIRRFED portal in a particular way. The way Sadaf and I run our platforms are completely different. And this AIRRFED portal does not put us under any yoke in terms of how we wish to express what we do. Our engineers need their freedom of expression. We do things in different ways based on legacy. And so having the top level portal and then separate portals on each site frees you from that kind of tyranny. Again, those local instances are graphical portal, allowing federated access to each site. Again, lowering barriers of access, increasing interoperability, enriching the user experience. I'm quite focused on this. How can these tools, there has to be something in it for every stakeholder. The allocators need something, service providers like me something, users need something. And for users, it's enriching that user experience, making it easier for them to access and use the site's HPC and AI resources via that kind of graphical portal, allowing, this kind of highly flexible science platform as a service model. And we can create a marketplace for kind of science platforms that can be instantiated with tools like Azimuth, for those that work with OpenStack HPC will know about. Yeah, so you move towards more of a national kind of cloud-like DRI. But this gives that kind of view of the top element. Well, I can't call it top, can I? Really, I don't know. What can I call that? Uber element? The kind of the allocator element, the allocator portal in magenta, in whatever that color is, magenta at the top, and then your federated platforms across Bristol and Cambridge, and you can just add on more. And it's a really elegant architecture in terms of those portals. And we've done a lot of work in Cambridge. That's why it's taken us a little bit longer. Bristol was more of a greenfield site, so they found it easier. We had to kind of integrate this portal in our legacy way of working with our LDAPs and the things that we have in Cambridge. And that's taken a little bit of time. I think we're almost there, like now-ish. I think we're going to put this into production next week. It just shows you that sites can be very different in the way that they operate and still be within this system. Gets back to your key principles of a federation. So this is actually that allocator portal. There's been lots of Simon McIntosh, very good with names. So he calls it airport, which is actually quite amusing. And there's a whole load of puns around airports and things, which is good. But this is that top level, okay, which exists as a demonstrator. And so it kind of shows kind of the workflows that you could imagine where allocators can use that airport as a single dashboard to allocate projects. And this kind of flows down through the business logic of the portals at each site. Yeah, so there's a good separation of business logic and science access. And this actually works, right, Sadaf? Yeah, this actually, I've never seen a live demo. And the thing that really impresses me with this is the speed, because it's API driven and these portals exist already. You're just linking together different APIs and it just kind of works. It's a really quick way of doing development, which changes the way we develop and support software. This is a snapshot of what that allocator portal looks like. It's really nice and functional. Sadaf has a demo that she can talk through at some stage. So if we move now down from the kind of allocator portal to the site-specific portals, what functionality do we have in there? We talked about this single sign-on capability. This is obviously key to allow authentication and identity management at those sources. You can also allocate, obviously, resources at that local level. So PIs can gain access to that local resource and see what's going on, allocate sub projects. I'm going to have to speed up. It's interactive. It's all the kind of things that you can see. Direct access with Slurm, K8s, a lot of work on TREs. This is kind of what that looks like within the Cambridge infrastructure layer, kind of Slurm, Azimuth and K8 environment, and it kind of abstracts up to be able to support workflows, allocations, reporting. This links into our support desk with Jira for onboarding and access. Okay. Again, more dumps of the portals, the views. This is aligned with Europe's direction, which I think is key. This is not something that we've invented left field. It's mainstream, this way of thinking. And here's my last slide. So status and next steps. So portals are being deployed and are production ready at Bristol and Cambridge. Bristol have about a 2-3 month leap on us there, but we'll be in production, I think, within the next month. All the goals and stretch goals of the project, are completed, which is a first for me. I'm lucky if a project finishes its goals, let alone stretch goals. But this project has been really successful in doing what it was set out to do. The Air Portal kind of top level demonstrator project is up and working. And I think it is allowing UKRI to imagine different ways of working because they can see it in front of them. We're continuing this work now with UKAA. You might not know this, Sean. I've described this. It's been agreed with Rob. And so UKAA are really interested in this for work that they're potentially doing with their AIGZ at Culham. Rob wants us to bring you into that federation and also link out to commercial cloud providers. So we can have a link into AWS. I think he's really keen for us to do that. We've got a lot of TRE projects underway. There's this project called Fridge, which is a DOI project, I think led by James Hetherington. Don't ask me what Fridge stands for. And we're also supporting another quite large medical AI project funded by DSIT called Pharos. Okay, the Dell and Intel have agreed to make AIRRFED a major theme within the Zettascale lab, which is cool because that unlocks quite a lot of investment from Dell and Intel in terms of continuing engineering support. And I think we need to explore, this is a conversation we had Sadaf the other day, it would be good to explore kind of how would projects like this be governed and how would development be funded, kind of breaking that kind of traditional mold of academic software projects, which I don't think are very successful, with a much stronger role for industry and how we create that kind of sustainable funding model for development, which could be pseudo-researchy, and then operationalizing, which is absolutely not. And I think we've never really, as a community, grasped that nettle on pseudo-research for features, but then how do you operationalize something? And what's the role of industry in that? I think we need to be a little bit more inventive there. And that's it.
Great, thank you, Paul. I think we've just squeezed in a couple of quick questions if anybody's got any.
Thank you. Yeah, very quick one on the operationalizing step. Have you thought about how you can avoid also losing your people if you're handing like these things over to industry? Like you want to make sure that
if my engineers go and work in industry, double their salary, and then support me through a commercial contract, everyone's happy. Really, it's our role. I'm happy with that.
Yeah, I would say this is something the UK is very bad at. So Stack HPC, it'd be interesting to have a longer discussion on how their commercialization came about, because there's a bunch of research tools that we could use to support AIR or elements of AIR, but they are very much developed out of research, out of the EU-funded projects, UK-funded projects.
A lot of these companies, as long as that commercial ecosystem is large enough and they can be selling to industry at a higher margin and us on a lower margin because they don't forget where they came from, then it works. And I know Stack have exactly that principle. Yeah, so I think it can work in for everyone if we develop these models. I think we just have to create a framework, have a vision, and then encourage that to happen.
Yeah. Can I add one more thing, Paul, quick? So everything is open source, open standard here. So you do not need money to use it. You need, like many software, you can get software for free, but if you want the support for extension, then you need it. So it's not designed that you need to put money up front to use it. It is completely open source, completely available. So that was the design principle. So not to kind of leave out people like in a smaller group or other
But then that
entities
also
to get
goes back to
started.
the funding model. We
Yeah,
need the
but that is the
funders to
software
support that
governance,
model.
and the model for open source software governance
Yeah.
is very well understood.
But for the funders,
Yeah,
they need to support, if we're going to have this
Yeah.
concept of ongoing support, there has to be that built in to the funding to the UKRI or UKAA
Yeah,
funding
yeah.
models.
Yeah.